Okay, a really weird thing about computational design is that even though we make automations, we help people be more efficient, our solutions are actually not very scalable. So if you ever make something for one person or a team, it's very different than making something for an entire company. It's really weird. So most people think software is you make once and you deploy it to many people, but computational design is a little bit different. So this video is actually about that, about why computational design solutions don't actually scale. The reason computational design doesn't scale as well is because of our tools. We use things like Grasshopper and Dynamo that gives us all this visual programming interface to do the things that we do, but it's really hard to get that to work on other people's computer, right? When you think about Grasshopper, everyone else needs to have Rhino installed. They have to have the same plugins installed. They have to have the same dependencies installed before they can even use the solution that you made. So even if you took 1 hour to make your solution, you might be spending the next 3 hours trying to get it to work on other people's computer. And it's just one other computer. Now imagine you deploy your script onto a couple hundred. So the tools that we use inhibit our ability to actually scale our solutions sometimes. But what we can do to help scale computational design solutions, it's by sort of raising the bar of what people know as computational design, right? If you're building a lot of Grasshopper scripts for people, maybe having a general workshop with everyone about what Rhino is, what Grasshopper is, will raise that level of understanding of what Grasshopper is. So next time when you make a script for someone and you send it to the other person, they are not super shocked. You don't have to worry about installing Rhino for them. You don't have to explain the difference between Rhino and Grasshopper with them. They will know that basic amount of information. That way you can deploy your scripts really easily, and if you have color conventions or naming standards for the scripts that you use, it won't be so overwhelming. They will immediately be able to see the inputs, the outputs, and work with the solution that you give them. So another thing that you can do to kind of help scale computational design is documentation or a handover process. Essentially, what you kind of want to do is just communicate, right? Write maybe a series of short instructions that walk them through step by step on how to use the script, where to click, what to expect, and how it kind of works. It's also good to list out what your solution doesn't do. That way they will understand when if something goes wrong, it's maybe just outside the parameters of the script and not their fault, right? Because most of the time, the tools that we work with, like Grasshopper and Dynamo, are not very good at giving out reasons why it's not working. So just having a email or a message with simple instructions of what the tool does or how to use it and what it doesn't do will go a long way. Now, another reason why scaling computational design solutions is so difficult comes down to maintenance. When we give people Grasshopper scripts or Dynamo scripts, there is no real way to maintain them properly. And because each script may need a slight tweak for a different project, maintaining updates and sort of bug fixes are really difficult amongst all the scripts. But the one thing you can do is put a version number on each script that you give out to people. So that way you can at least track what different versions do, right? So even if they made slight changes to version 1, at least when I give them version 2, I can understand the difference between the version that they have and the version that I'm working with. It doesn't solve everything, it's still not a perfect solution, but it does make tracking all these bugs and weird tweaks a lot easier. Okay, so scaling computational design solutions is not natural. It's not something that comes instinctively with any of the programs that we use. So it takes effort to scale these solutions up. And even when you do put in the effort, sometimes it doesn't pay off, right? You're still going to have all these weird problems that you have to solve because we are stuck to using tools like Grasshopper and Dynamo. Sometimes those can mean really weird instructions to our users. It's also our job to make them less overwhelming for the people that want to use our solution. So even though it does take extra effort, it does mean you create solutions that are more widely used. It just means that the friction between what you make and what people will use is lower. And I think that's always worth the effort. So thank you so much for listening, and I'll see you in the next one.